Hello everyone and welcome to MV Tutors. It's been a minute, but we are back. And so we're looking at the prelim written in Gauteng, paper 1 on the 9th of September, right? So yeah, don't forget to like our videos and also subscribe to our channel. And guys, as we're doing this memo, please, if you see any silly error we've made or any mistake we've made, please do correct us. We're all here to learn. But yeah, let's attempt it and let's see how it goes. Okay, so question 1. We are solving for x. Guys, this is a section where you should be bagging those marks, okay? I mean, if you look at question 1, it's 27. So please, that's almost like, what? 27 out of 150? Yeah, it's a lot. It's almost a fifth out of the paper. So let's try to get as many marks as we can. All right. Yeah, so let's see. Question 1. Solving for x, 1.1.1. We have 2x and then x squared minus 1. So this is a cubic function. We are expecting at least 3 values, not at least, at most 3 values for x, okay? So it's nice that they put it in brackets for us, but we can expand it further because we have a difference of 2 squares. So that would be x minus 1, and then we have x plus 1, and that is 0, and then now we can solve. So we have 2x is equal to 0, or x minus 1 is equal to 0, or x plus 1 is equal to 0. And therefore we have x equal to 0 as our first solution. Then we have x is equal to 1 as our second solution. And then we have x is equal to negative 1 as our third solution. And what you would then do afterwards is check if your answer works. So go and substitute 0. If you substitute 0 there, you'd see that your answer will be equal to 0. If you substitute 1, you would get 2 here. And then inside you would have 0. So therefore it's equal to 0. If we substituted negative 1, you'll have negative 2 there. And then you have negative 1 squared, that's 1. 1 minus 1 is 0. So therefore, all the answers here work. Don't forget to check your answers, okay? I forget most times. If you've been doing question 1 with me for a while, you'll see that only later I realized, like, snap, I should have checked the answers. All right, and then 1.1.2, we should solve again for x, but as soon as they say correct to 2 decimal places, that should be a hint that you should be using the quadratic formula. Okay, so let's write it down. We have x minus 6 plus 2 over x is equal to 0, and we cannot have x equal to 0 as a solution. Okay, so we have a fraction. We don't like working with fractions. We want everything like, you know, no steps. We want straight line. So we're going to multiply everything by x, okay? So if I multiply by x throughout, I would have x squared minus 6x plus 2 is equal to 0 times x, which is 0. Okay, now we have something we can work with. And because I know I'm going to be rounding off to 2 decimal places, I'll be using the quadratic formula. Okay, so x is equal to, remember, it is minus b plus minus b squared minus 4ac. Everything under the square root is also known as the discriminant, all over 2a. Okay, so this is just a reminder of what the formula is. If you forgot, I think they do provide it in the formula sheet. They should. I'm not going to check it. So, minus b. In the place of b, we put minus 6. Okay, plus minus, and then we have minus 6 squared, which should be 36, minus 4a, which is 1, c, which is 2. Okay, let's extend that square root line, and then 2 times 1. And this is where you plug everything in the calculator, and then you're going to get 2 solutions, or x is equal to. For this one, I will not be checking if it's equal. Okay, I should. I'm saying that because you need to save your answer, or else you're not going to get it being equal to 0. But anyway, let's just put everything in a bracket. So minus minus 6, I'm just going to put a positive 6 there. I'll start with the positive version of the answer. So that will be 36 minus 8. Okay. Put everything in the calculator as it is. Yeah, it just takes time having to calculate everything. So we have 5,65 as one solution. 5,65. I'm so not going to check it. I said I won't, but let me just do it. If I take this answer and I put it back in the original equation, so I would have answer, no. Okay, there's the answer. So if I say answer minus 6 plus 2 over answer, I get 0. So the solution works, right? We are happy. Okay. Now let's go back to the, oh, snap. Let's just redo it again. Now we're looking at the negative version. Okay, so we have positive 6 minus square root. 6 squared is 36 minus 8 all over 2. And then we have 0,35 as another solution. Okay. While we have that answer in the calculator, we're not going to use the rounded off version. We're going to check whether this answer also works. So we will then say answer minus 6 plus 2 over answer. Yo. Okay, but this is significantly small. It is negligible, so I would say the answer works. If you're getting 17,7 to the power negative 16, it's a very minute number, so I will let it slide in this case. Okay, so we have our two answers there. And then we move over to 1,1,3. Okay, so we have inequalities there. Okay, x plus 4. All of that is bigger and equal to 6. I know the temptation here is to say, well, since we already have the brackets, we could say x minus 1 is bigger and equal to 6, x plus 4, or x plus 4 is bigger and equal to 6. But I prefer multiplying it out, taking 6 to the other side, getting new x-intercepts, drawing the figure, and then finally finding out what the answer is. Okay, I'm going about it the long way, but it's a way that I understand. Okay, so if you multiply out the brackets, we're going to get x squared, then we're going to get minus x plus 4, so that's just plus 3x, and then minus 4, bring the 6 to the other side, that will be minus 6, bigger and equal to 0. And so if we simplify that, it would be x squared plus 3x minus 10. Okay, and that would be bigger and equal to 0. So the factors of 10, that will give me 3. I'm thinking 2 and 5. All right, and we have a negative 10, so that helps as well. So for those of you who are not so good with using factors, you can always use the quadratic formula. Okay, rather be comfortable and sure than unsure and getting, the wrong answer. Okay, so we have my plus 5 minus 2 will give you plus 3. Okay, and all of that is bigger and equal to 0. So I have my two x-intercepts, right? The intercepts will be 2 and minus 5. So if I were to draw my number line, and I have my quadratic formula there, which is a smiley face. Okay, I know one of the intercepts is minus 5, and then I have 2. Okay, and they're both solid dots. So they're saying x minus 2 times x plus 5 is bigger and equal to 0. If it's bigger and equal to 0, we're looking at the region on top here. Okay, and now if we're looking at the region on top, our answer will be here, basically. I hope it makes sense. If our answer was smaller and equal to 0, we'd be looking at the region at the bottom, okay? And that means our answer would lie inside here. But that's not what we have. We have it being bigger and equal to 0. So in that case, our final answer will then be, so we have minus 5 as one of the factors. So basically x will be smaller and equal to minus 5 because the answer goes in this direction. So it has to be smaller than minus 5. Please excuse my blocked nose. And then we have x, because it's going in that direction, will be bigger and equal to 2. And those are our two solutions. Okay. Cool. So now let us go to 1.1.4. Okay, so now we have some roots there. Just like fractions, we do not want to work with roots. Okay, so if you can, by all means, please get rid of those roots. Okay, so firstly we have a fraction, so I'm going to multiply it out, okay, so that I can have everything on one line. Then we'll deal with the root. Okay, so we have x minus 2 rooted, going to multiply it with x minus 2, okay, then we're going to multiply the 3 by root x minus 2, and that will be equal to 10. Okay, so what I see here, I'm basically going to have x minus 2 squared, okay, plus 3 times x minus 2 minus 10. Alrighty, so for those who are not seeing this, you could basically make or root x minus 2 equal to y, okay, and if you have that, you would then say y squared plus 3y minus 10 is equal to 0, if you want to make things simpler for yourself. But if you can see it, stick to it. I think I will make, yeah, maybe rather put it like this. I think I will make root x minus 2 equal to y, okay, because I don't want to work with these square roots and fractions and all of that. So if I can make my life simple, I will do that. But if you want to continue with the root x minus 2, by all means do that. Okay, so I don't know if you realize y squared plus 3y minus 10 is similar to what we just did previously. It's just we had an inequality there. So I know then I will have my answer as y minus 2, y plus 5 is equal to 0. Okay, therefore y is equal to 2 or y is equal to minus 5. But we are not solving for y. We are solving for x. So I have root x minus 2 is equal to 2, or sorry about that, x minus 2, root x minus 2 is equal to minus 5. So if I take the square root to the other side, I'll be squaring. This is what I mean. I'll be squaring both sides because I want to get rid of that square root. Okay, so I'll be left with x minus 2 is equal to 4. And then I have x minus 2 is equal to 25. Okay, then I have there that x is equal to 6. Okay, if I take 2 to the other side and this side, I have x is equal to 27. At this point, I really need to check if the answers do work out. Alright, so let us see. If I plug in froze for a minute there. If I plug in x is equal to 6 on the left hand side, let's see. So I have there 6 minus 2 plus 3. Okay, so the answer is 5. Okay, just store that in your mind. The answer is 5. Now let's check what's happening on the right hand side. Okay, so on the right hand side I have 10 over root 6 minus 2. Okay, so the answer is 5. Great. So the solution works out. X is equal to 6. Now let us check x is equal to 27. Will it work out? I'm going to have to take a break and cough. Okay, 27 minus 2 plus 3. I get 8. Okay, great. Now let's check on the other side, the right hand side. If I have 10 all over 27 minus 2, I get 2. Okay, so the right hand side is not equal to the left hand side, so the solution will not work. Okay, so we have x is equal to 6 and we have x is not equal to 27. All right, so that's 1.1.4. Let's take a little bit of a break and then we'll solve 1.2. Okay, let us do 1.2. We are solving simultaneously, okay, for x and y. Now let us see. I have x minus 2y is equal to 1. And then I have, what a long one, 2x squared minus xy, I hope it fits, minus 5y minus 3y squared minus 2 is equal to 0. So we are going to write in terms of x. I think it's easier that way. I'm trying to avoid fractions. I'm not going to write it in terms of y because that will force us to divide everything by 2. So then x is equal to 2y plus 1. And I'm just going to say that is like my first equation. That is my second equation. So I will substitute x into the second equation. Okay, so substitute 1 into 2. Okay, when you write these answers, you must guide the marker so that they don't wonder what's happening here. All right, so if I put x there, so I have 2x squared. X is 2y plus 1, okay, squared, minus 2y plus 1 times y minus 5y minus 3y squared minus 2 is equal to 0. Okay, things are fitting. All right, now let's multiply out this bracket. So we have 2, and then that will be 4y squared. 2y times 1 is 2y, plus 2y, that will be 4y. So plus 4y, and then plus 1. If I multiply the y inside here, okay, so I will get negative 2y squared minus y minus 5y minus 3y squared minus 2 is equal to 0. So let's just take out the brackets. So I have here 8y squared plus 8y plus 2. I'm just going to group whatever's there already, okay, so that I don't have to rewrite everything. So minus 2 minus 3, that is minus 5y squared, minus y minus 5, that is minus 6y, minus 2 is equal to 0. So again, I'm going to group the like terms. Okay, so 8y minus 5y, that will be 3y squared. Sorry, 8y squared minus 5y squared. And then 8y minus 6y, that will be, yeah, hey, flew. Okay, 8y minus 6y, that will be 2y. And then we have 2 minus 2, that's 0. Okay. I think it makes life a little bit easy for us. So I'm going to take out the common factor, which is y. I'm left with 3y and 2. So therefore y is equal to 0, or 3y plus 2 is equal to 0. 3y is equal to negative 2. Y is equal to negative 2 over 3. Why are we having fractions? Why is y doing this to us? Alright, so we have these two solutions. Y is equal to 0 and y is equal to negative 2 over 3. Okay, now we need to solve for x. Okay, remember we wrote x in terms of y. So I'm just going to have a little partition here. Just to show that the answer for y is equal to 0, I'm going to use it for x now. So x, we said it's equal to 2y plus 1. x is equal to 2y plus 1. Therefore, x is equal to 1. We also need to test this, okay? And here, x is equal to 2y plus 1. So we have negative 4 over 3. I'm going to write 1 as 3 over 3 so that I can, have one common denominator. Minus 4 plus 3 is minus 1. So I have negative a third. Okay. Should I really test this? Yes, we should. So, x minus 2y. So for the first, one, we have that x is 1 and y is 0. Okay, so x is 1 and y is 0. Alright, and that should equal to 1. Okay, so that one, it works. The second one, we have that x is negative a third. Okay, minus 2y, minus 2. And what is y again? Y is negative 2/3. So negative 2 over 3. Okay, and that is also equal to 1. So we are good. It's good to check. It didn't take that long. So yeah, x is equal to negative a third. Oh, are we finishing? No, we still have 1,3 and 1,4. So it says we are given 2 to the power x plus 1 plus 2 to the power x is equal to 3 to the power y plus 2 minus 3 to the power y. Now, x and y are integers, meaning we are not going to get fractions here. If you start getting fractions, there's a problem. And then determine the value of x and y. Okay, let's do it. Let's take common factors out. It would have been nice if this plus was a multiplication sign, hey? We just add the exponents, but that's not the case. So I'm just going to write this as 2 to the power x times 2 to the power 1 plus 2 to the x. Okay, just separate it a bit so that we can see what do we have here, what can we do, what can't we do. Okay, so I'm going to take out the common factors. So on the left hand side, the common factor is 2 to the power x. So I'm left with 2 plus 1. On the right hand side, I have 3 to the power y. I'm left with 3 to the power 2 minus 1. So basically that is 2 to the power x times 3. And here I have 3 to the power y. 3 squared is 9, okay? And 9 minus 1 would be 8. 8, I'm going to just, 8, I know that it's 2 to the power 3. And I'm glad I have 8 so that I can have 2 to the power 3 so that I have bases that are like 2 and 3, okay? So let me just put it like this. So let me just put the 3 in front. 3 times 2 to the power x. And then I have 3 to the y times 2 to the power 3. So now I have, similar bases. I can make the ones with the same base equal, and then we can solve x and y. So, and we can check our answer afterwards. So 3 to the power 1 would be equal to 3 to the power y. So y is equal to 1. And on the other side, I have 2 to the power x, which is equal to 2 to the power 3. So x is equal to 3. That's great and all, but does it work? Does it work? So if we then take the left-hand side, let's just check what the left-hand side will give us. And the left-hand side has to be equal to the right-hand side. So let's just take out our calculators. So we have 2 to the power x, and we said x is 3. So 3 plus 1, okay, and then plus 2 to the power x, 2 to the power 3. So on the left-hand side, we have 24, okay, We have to get 24 on the right hand side or else I don't know what to do. Okay. So on the right hand side we have 3 to the power y. Y is 1 plus 2, and then minus 3 to the power 1. Okay, and that is 24. I'm happy. I can move on with peace. Okay, the last question for question 1. Alright, so it says the equations x squared plus 3x plus m is equal to 0. And again, we have x squared plus mx plus r is equal to 0. And they have real and equal roots. Okay, that's where we discuss the discriminant. If it has real and equal roots, basically, if you have your quadratic equation, real and equal roots mean you have a turning point. Okay, but in terms of calculations, what does that mean? Okay, let me just write down the 2 equations. So I have x squared plus rx plus m is equal to 0. And then we have x squared plus mx plus r is equal to 0. The discriminant, if you have a look at your quadratic equation, it is basically what's under the square root. Okay, so what is under the square root? That's basically, let me just remind you of how the quadratic equation is. So minus b plus minus b squared minus 4ac. So basically b squared minus 4ac, that is your discriminant. I hope I'm using the right term. I've been saying discriminant. I hope that is the case. So our discriminant then, if we have real and equal roots, we make it equal to 0. Okay, so yeah, it has to be equal to 0. Alright, now let's look. Our discriminant, so it's b squared. So in this case we have r squared minus 4ac. Okay, on this side as well we have m squared minus 4ac is equal to 0. Okay, so let's solve and let's see what the values of r and m are if r is bigger than 0 and m is bigger than 0. Okay, so r squared, I basically get it being equal to 4m. And then this side I have m squared equal to 4r. So what am I going to make in terms of what? Let me just use m. Let me say m is equal to r squared over 4. Okay, that's my first equation. So I'm going to substitute my first equation into my second equation. So m is r squared over 4. So I have r squared over 4. All of that is squared. Okay, because that is m squared, which is equal to 4r. So r squared is basically going to be r to the power 4. And 4 squared, that is 16, equal to 4r. And then I have r to the power 4 is equal to 16 times 4r. Okay, I'm going to take out the r on the right hand side, divide by r both sides, so I'll be left with r cubed. And since 16 is 4 squared times 4, that will also be 4 cubed. So basically r is equal to 4. Okay, great. Now let us go to getting m. We said m is r squared over 4. So we're going to substitute r into our first equation. Okay, no, I forgot it. R squared over 4. So we know that We have 4 squared over 4, and that's basically 4. So m is also 4, and both of them, r and m, are bigger than 0, so I think we're done. Okay, and that's it. We're done with question 1. Whew. Question 2. See you later. Hello everyone, and welcome back to MV Tutors. I'm Tsulu, and I'll be looking at question 2 with you guys. Please don't forget to like our videos and subscribe to our channel. Yeah, I did question 1 and I'm doing question 2, and I'm thinking, should I publish it now? Because I know you guys are preparing for paper 2. But yeah, we'll see. Maybe I'll just wait for you to finish paper 2 and then publish these answers. Yeah, because today is the what? It's Saturday the 10th. Okay, so question 2, we have the quadratic sequence. Yeah, quite a nice sequence. We only have a sequence, there's no series for it. Yeah, so basically we have 20 and 12, 10, 14. The one thing I wanted to mention, guys, when you answer questions, please make sure that you are also answering speedily. I know sometimes rushing can make you or can result in errors, but just check your time. And if you want to know how much time you should be spending on a question, this is a 150 mark paper. No, yes, 150 mark paper, and you're given 3 hours, okay? 3 hours times 60 gives you 118 minutes. So you're going to take 180 minutes divided by 150, you're going to get 1.2. So each mark you should be spending 1.2 minutes. Okay, please learn how to time yourself so that you don't end up not finishing your paper. So as you also practice for the final year exams, please work on speed but accurately as well. Hence we keep checking our answers. Okay. So we have that quadratic sequence, and now we need to determine an expression for the nth term. Okay, so we're going to start by checking out what is the first difference. So 12 minus 20 will give us minus 8. 10 minus 12 will give us minus 2. 14 minus 10 will give us 4. Alright, and then minus 2 minus minus 8, which is minus 2 plus 8, that'll give us 6, and 4 minus minus 2, which is 4 plus 2, that will give us 6. So because we're getting a common difference in the second difference, I'm happy. I feel like, yes, we've worked it out correctly. Now we need to get the equation, okay, of this quadratic pattern. So what do? We look at the first column. First diagonal column. Yes, let me just say that. We're going to look at the first diagonal column. Okay, this we're going to make equal to 2a. This we're going to make equal to 3a plus b. And this we're going to make equal to a plus b plus c. Okay, then we can solve and get our answers. So 2a is equal to 6. Therefore, a is equal to 3. 3a plus b is equal to negative 8. So 3 times 3 is 9. Negative 8. So if I take 9 to the other side, I will have minus 8 minus 9. That's minus 17. I'm like, whoa, these are big values. So a plus b plus c is equal to 20. Okay, a we have 3, b we have minus 17, plus c is equal to 20. 3 minus 17 is minus 14. If I take minus 14 to the other side, it will be plus 14. So c is equal to 34. These answers are big, and that is why we should check, is this actually correct? So we have 3n squared minus 17n plus 34. We just pause a bit. So how will we check our answer? Well, basically we had the quadratic pattern, so I can test to see, this is term 3, right? Oh, guys, please excuse the sound outside. Yeah, but let us see. What will term 3? Term 3 has to give us 10. Okay. So 3 times 3 squared minus 17, 3 plus 34. We have 10. Okay, let's test maybe the first term just to be sure. Okay, if I use the first term there, I should be getting what, 20, ne? And we get 20, so this works. Okay, so we are happy. We are getting our 4 marks. And then now 2.1.2. Now it says the first differences form an arithmetic sequence. Yes, that is true. Now it says determine between which successive terms in the quadratic sequence the first difference will be 148. Guys, they love this question, especially in grade 11 papers. I feel like I've been doing it so many times. So what are they saying? Okay, so we have our quadratic pattern, right? So you can see the first difference, we're getting minus 8, minus 2, 4. At some point, we're going to get some term, okay? And we're going to get the next term, which is just tn plus 1. And between those two terms, the first difference we're going to get is 148. Okay, so I'm saying tn here because I don't know what n is. I don't know that nth term. I don't know. It could be term 50. It could be term 25. It could be term 103. We don't know. So we just put tn. And here I put tn plus 1 because obviously this is t1. This is t2. t2 is like t1 plus 1. Okay, hence we say tn plus 1 because we don't know what n is. But we know that the next one is just plus 1. Okay, I hope I made sense. I hope you got it. And the difference between those two terms, which is the first difference, which is the, what do you call this, the arithmetic sequence, that first difference is 148. So normally, how do I get this 148? How did we get this 4? We said 14 minus 10, then we got 4. So we're going to do the same thing, same concept. So we will say tn plus 1 minus tn, okay, will give us 148. This is what this question is asking, okay. So, yeah, 3 marks. Okay. I feel like it's a lot of work for 3 marks, but let's work. Okay, so now we look at our tn equation, but we're going to put n plus 1. So 3 n plus 1 squared minus 17 n plus 1 plus 34. Okay, all of that I'm subtracting 3n squared minus 17n plus 34. And all of that should be equal to 148. So if I multiply out, sorry guys, my nose is itchy. It's itchy and I have a blocked nose. Ugh. Bad combo, but this is the only time I have to record. So let me use it. So please bear with me. So n squared plus 2n plus 1. Then I have minus 17n minus 17 plus 34 minus 3n squared plus 17n minus 34 minus 148 is equal to 0. Okay, it's equal to 0. Okay, so I can already see, let me just remove what I can, minus 17 plus 17, 34 minus 34, okay. Makes life a bit easy. We're cleaning up a bit. So I have 3n squared plus 6n plus 3 minus 17 minus 3n squared minus 148. Okay, So I can already remove those two. So I have 6n, and I will not be calculating that with my head. That's what calculators are here for. So 3 minus 17 minus 148, it's negative 162. I'm just going to take it to the other side. 162. So n, by the way, n cannot be a fraction. Okay, it has to be an integer. Actually, it has to be a positive number, whole number, positive whole number. So I have 162 divided by 6, and we get 27. Ah, beautiful. I was going to have a little bit of a heart attack if it was not a positive whole number. So now we know Tn, the terms, because the question is determine between which successive terms. Okay, so it will be T27 and T28. Okay, 3 marks. Should have been 5 marks, ne? 2.1.3. So now it says determine the smallest value of n for which the sum of the arithmetic sequence is bigger than 10140. So bigger than 10140 or 10,140. Let me rather put it like that. 10,140. So now the sum formula, remember the first difference is our arithmetic series, okay, was rather sequence, but yeah, in this case it would be a series. So we have minus 8, minus 2, and 4. Okay, and just put it on the side. We have minus 8, minus 2, and 4, and the common difference was 6. So that is D, and that is A. So the sum formula, basically that's n over 2, then we have 2a plus n minus 1 times d, and that is equal to 10,140. So we are looking for n. All right, we have a, we have d, so let's solve for n. Okay, a is negative 8, so we have 2, negative 8. My son wants to come and record with me, but that will not be productive, so he has to go. And then n minus 1, d is 6. Okay, and all of that is bigger than 10,140. Okay, I'm going to multiply by 2 so that I have a straight line. No fractions. So I have n over here. I have negative 16. Then I have negative 6. Okay, negative 6. And then I have plus 6n. Okay, all of that, if I multiply 10,140 by 2, 20 to 80. Yeah, that I could have done by head, but anyway. Okay, so we are getting somewhere. Let me just multiply the n inside. Okay, so this will give me negative 22. Okay, so I have 6n squared minus 22n. I'm going to bring the 20,280 to the left side. So negative 20 to 80 bigger than 0. And here, guys, we just use quadratic formula. You can divide by 6, no, by 3 or whatever, but yeah, 3 won't even work. Okay, had to blow my nose there. All right, so quadratic formula. So now we have n instead of x minus b. So minus minus 22 minus b plus minus b squared minus 22 squared minus 4ac. Okay, and all of that is under the square root. Then we have 2 times 6. Okay, plug all of this into the calculator. Okay, so we have 22 plus square root 22 squared minus 4 times 6 times negative 2280 all over 12. Okay, we get 60. All right, so n is equal to 60, or we have to test this afterwards. All right, or no, this definitely not gonna work. So n is definitely not equal to negative 56.33. Remember, for n you must get a whole number. Okay, you can't be getting a negative, nor can you be getting a fraction or a decimal. Okay, so n is 60. Is it though? So we're going to go to our original formula here, and we're going to substitute n. Okay, and if you don't get a number bigger than 10,140, we are in trouble. So n is 60. So we have 60 over 2. Okay, and then into brackets we have 2 times negative 8 plus another brackets 60. I'm just going to put everything as it is. So 60 minus 1 times d, which is 6, and then okay, so it is 10,140 exactly. All right, so we are not going to use 60. We have to use 61 because they said it must be bigger than 10,140. So actually here I should say that n should be bigger than 60. Okay, so n can be 61, n can be 62, and all the way. Okay, so that is 2.1.3. We are almost there. So 2.2. Now the sum. Yeah, I hope this has been clear the entire time. Sorry if it was too small. So, my son, they gave them these things at creche, and now he's making a lot of noise. So I might be pausing to go and reprimand and then come back to finish up the question. But let's just see if he misbehaves. So we have the sum, right? Now it says determine B in terms of A. So because I see here I have only 5 terms to deal with, how do I know that I have 5 terms? By the way, this is the summation sign. Well, this is the summation sign, okay? Basically it's saying if I keep adding R plus B for the first term, for the second term, third term, fourth term, fifth term, I'm going to get an answer of 10A if I add all those things up. So how do I know the amount of terms I have? Well, basically n, number of terms, is the top term, 5, minus this 1, and then we add 1. So I have 5 terms. So, I would then say term 1, if I'm doing it the long way, I'm going to do it 2 ways so that you can, okay, the long way, you shouldn't be doing it. I'm just showing you that you're going to get the same answer, but you must always use the formula. So if I use the first term where R is equal to 1, this will definitely be 1 plus B. Second term, I would get 2 plus B. Third term, you can see where this is going, right? So basically, if I add on all these up, I should get 10A, or I should make it equal to 10A. So if I add 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So basically I have 15 plus 5b being equal to 10a, because that's what they said. Now they said write b in terms of a. So I have 5b is 10a minus 15. So if I divide by 5, I will get 2a minus 3. So that is the answer. But what if you had 100 terms? You can't do that. You can't do it the long way, so we have to use the formula. Okay, so I know the number of terms, 5. I know, well, I can get the difference between two terms. So T2 minus T1 will be 1. So that's basically D. Okay, I have N, I have D, and then A is basically 1 plus B. Okay, and I can see this is an arithmetic series. Okay, series, not sequence. It's an arithmetic series. So I have to use the sum formula. Okay, that is the wise way to do it. I showed you the long way to do it. Now let's use the wise way. So basically we know the sum formula. We did it previously. N over 2 times 2a plus n minus 1d. Please use the formula. Don't go about it the long way, unless if you really are in a stuck between a rock and a hard place, or if maybe you have 2 or 3 terms to deal with. Okay, so the sum of all of these terms is equal to 10a. Okay, and n is equal to 5. A is 1 plus b. Okay, n is 5, so 5 minus 1 is 4, and d is 1. Okay, so I'm going to remove the 2. I don't want fractions, so I'm going to have 20a is equal to 5, and in the brackets I have 2 plus 2b plus 4. So if I simplify that, actually this 5 I can also divide it. Right, so 20 divided by 5, that's 4. So I have 4a is equal to 2 plus 4 is 6 plus 2b. And I should write this thing in terms of b. So I'm going to take 2b to the other side and move 4a to this side. So I have 6 minus 4a. So 4a went there, 2b went there. Ooh, it should be negative. If 2b goes this side, it's negative. The danger. See what the danger is? Okay, so if I divide by negative 2 throughout, I will have that b is negative 3 plus 2a. Okay, or I would say 2a minus 3. And how many marks was this? 3 marks. I think it's fair. Okay, so 2 ways of doing it, but please use the formula. Identify what kind of series you have. Is it arithmetic series, or is it geometric? And then use the relevant sum formula. Okay, so yeah, we're done with question 2. See you next time. Hello everyone, and welcome back to MV Tutors. You're still chilling with me. We're doing question 3 now. Alright, still at it with the sequences. Alrighty, please don't forget to like our videos and subscribe to our channel. Please share this info with your fellow classmates, okay? And let us be successful in this maths thing. If you see or recognize any error I've done, please correct me in the comment section. If you benefited from this, please also just comment. It would be nice to get some feedback from you. Say something. Alright, question 3. Yeah, let's get to it. So it says, given the following geometric sequence, okay, we have 24 over x, and then we have 12, Then we have 6x. Oh, this is a series, right? We're adding. Ugh, it's fine. Then we have 3x squared. Okay, so what I'm seeing here, if I'm just looking at the numbers, we are dividing by 2. Okay, so 24 divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So we are multiplying by a half, definitely. Okay, in terms of the numbers. I'm not too close to the screen. In terms of the numbers. And then, in terms of x, I think we are multiplying by x because x disappears in the second term. So if I say 24 over x times x, obviously the x's cancel, times a half is 12. So I'm basically multiplying by a half x, okay? And 12 times half x will be 6x, and 6x times half x, it will give us 3x squared. So basically this is our common ratio. And don't forget how you get your common ratio. You will say your T2 divided by T1. Okay, that's the simplest way to do it. 12 divided by 24 is a half. 1 divided by x is just, never mind. But anyway. Yeah. So yeah, T2 over T1. That's how you get the common ratio. Now, yeah, it's actually 1 divided by 1 over x. Yeah, I couldn't just let that go. 1 divided by 1 over x is x. So now 3.1. Calculate the sum to infinity of the series. Remember the equation? Yeah, I do, but let's just go and have a look at the equation. You've got to be kidding me. Ah, my husband did not scan the last part. The formulas are important, love. Okay. Anyway, it's all good. So the sum to infinity of a series, this is how it is. Sum to infinity, it's a over 1 minus r. Is it 1 minus r or r minus 1? Let me just check with my notes. Where's the thing? Where's the sum to infinity? 1 minus r. Okay. And the condition is that r should be in between -1 and 1. Okay, that's the condition. So now, yes, calculate the sum to infinity. So what is our first term? Our first term is 24 over x. Okay. Then 1 minus the common ratio, which is a half x. I'm going to say half x. Okay, and then, yeah, we must simplify this. So let me just say 24 divided by x divided by, okay, let me put it like this rather. 24 over x, okay, divided by 1 minus x over 2. So we have 2 in the denominator, and I need 2 there, and then that will be minus x. I don't see things cancelling here. Okay, so they didn't say in terms of x, but I don't see how x will be gotten rid of. Okay, so if I do this, I'm gonna get 48 on top, and at the bottom I am going to get 2x minus x squared. That is the sum to infinity. Yeah, hey, that is in terms of x. If it wasn't going to be in terms of x, so if I were to put r as half x, just say x over 2, just to simplify it. Maybe we're supposed to come here, x over 2 minus 1, 1. So x would either be minus 2, or nah, still we don't know what x is. it can be in between -2 and 2. But as for the exact value, we don't know. So I can't even use this portion. I think it can be left in terms of x because the x's are not cancelling out at this point. Yeah, they're not. Okay, let's move on. 3.2. You can comment below if you get something different. Write down the values of x for which this sequence converges. Okay. This is where we use the condition -1, 1. We already did this. So this is x over 2 if the series converges. So -2, x, 2. Cool. Let's see the marks. 4 marks. Hey, there's 2 marks I believe. But for what we did in 3.1, I don't see us getting 4 marks. 3.3, for which values of x will the series increase? So the series will increase if r is bigger than 1. Okay, we know that r is x over 2. So therefore, values where x is bigger than 2, that's where the series will definitely keep on increasing. And then 3.4, if x is equal to 4, determine the sum of the sequence to 15 terms. Okay, so now we need the sum formula. The sum formula, I believe, it's a fraction. I need the formula. Let me just get it quickly. Sum formula, it's a r to the power n minus 1 over r minus 1. Okay, so what is if x is equal to 4? So basically, if x is equal to 4, r x over 2, 4 over 2, so r would be 2. Okay, how many marks is this? 4 marks. Okay. So a, what is a? A is 24 over x. So 24 divided by 4 is 6. Ne? Yeah, 6. That's a, and then r is 2 to the power n, 15 terms, right? So 2 to the power 15 minus 1, and then again we have 2 minus 1, which is just 1. So we have 6 times, 2 to the 15 minus 1. This is what we're going to put in the calculator. And then the denominator falls away because it's just 1. So let's see. Okay, so we have 6 times 2 to the power 15 minus 1. Okay, so 196,602. Yeah? Yeah, 602. So that is the sum of the sequence to 15 terms, and this is it with question 3. Hello everyone and welcome back to MV Tutors. We quickly rushed through question 3 so that we can get to question 4, functions. I heard that this can be a thorn in some people's fleshes. So let's see how we can best explain this. And yeah, please don't forget to like our videos and subscribe to our channel. Please do comment below for anything, for any areas you noted, any comments, room for improvement. You know, we're here to serve you, so help us serve you better. All right, question 4. We have a hyperbole. Hyperbole is there in English. This is a hyperbola or hyperbola. Ooh. So we have a hyperbola with the equation g of x, and we have a quadratic function, the f of x. Okay, they are sketched. We have a, which is the one of the x-intercepts of the quadratic function, and then p is the turning point of f and lies on the vertical asymptote of g. Then the vertical asymptote passes through 1, okay, they're on the x-axis, and then the horizontal asymptote passes through 2, okay, on the y-axis. So graph G passes through the origin. So one of the points on graph G is 0, 0. Okay, one of the coordinates. Now, what do they want from us? Show that the equation of G, the hyperbola, can be written as follows. Y is equal to 2 over x minus 1 plus 2. Okay, so you know if we have our equation here, g of x, this is question 4. Let me just do this. Okay, so we have g of x, which is basically a over x plus b plus c. So they told us the vertical and the horizontal asymptotes. B, in this case, representing the vertical asymptote, will be equal to -1. Okay, because x at this point, x is equal to 1. So how do we get 1? We would say x minus 1 is equal to 0. Hence, x is equal to 1. So that's why b has to be -1. Okay, so b there is -1. And then what about c? Well, c is straightforward. The horizontal asymptote it passes through 2. So c will be 2. Okay, and then we have a point on this hyperbola because they told us it passes through the origin. Oh, now I'm putting P. Mommy. Yes, Pisani. Look. What is it? Look. You're wearing my watch? Ah, it's Auntie Dinky's watch. Okay, close the door. Close the door, my baby. Okay, so at the origin we have the coordinates 0, 0. So I can basically substitute everything. So I'm going to put 0 here. I'm going to put 0x. A is what? I don't know. I can substitute -1 for B and 2 for C. Okay, so let's write it down. 0 is equal to A over 0 minus 1 plus 2. If I take 2 to the other side, I have -2. A over -1, which is just -A. So negative A, so basically A is equal to 2. And we have shown that because ultimately we can say Y, like they said, is equal to 2 over x minus 1 plus 2. Okay, so that is what, 2 max 3 at least. Okay, so 4.2, calculate the coordinates of P. So that is your turning point. Okay, what do we know? We know the x coordinate of P. Okay, so we know that P has an x coordinate of 1, but what would be y? Okay, so we know the x coordinate of the turning point. We have a point, the x-intercept, which is 5 over 2. So let's look at the equation that has been given to us. Okay, we have f of x is equal to x plus p. Remember PQ, turning points, right? So we have p is -1. Okay, the minus. So when it comes to horizontal shifts, guys, if it's to the right, minus, to the left, plus. Okay, so yeah, so here we have -1 for P. Okay, Q, we don't know it, ne? We don't, but we have a point on this graph, ne? And this point is 5 over 2, 0. So the x coordinate is 5 over 2. Okay, and then the y coordinate is 0. Okay, so our only unknown here is Q. You know what are we looking for? We're looking for yes, the y coordinate. We're looking for Q basically. So if we solve for Q, I'm just gonna put Q this side. So negative Q is equal, so 5 over 2, that's like 2.5. 2.5 minus 1, that's 1.5. 1.5 is like 3 over 2. Okay, so and yes, the y value should be a negative. I'm hoping that you are seeing this. It should be a negative because P is there by the negative y-axis region. Okay, and 3 squared, that would be 9. 2 squared, that would be 4. Okay, so Q is negative 9 over 4. If you wanted the decimal, I think it's 2.25. But let us check. We have the calculator there. Yeah, 2.25. So Q negative 2.25. So ultimately the coordinates of P1, I'm just going to put the fraction. Yeah, okay, so that's 4.2. And now 4.3. Write down the equation of the vertical asymptote. We know currently the vertical asymptote of G is x is equal to 1. Okay, now it says write down the equation of the vertical asymptote of P. So basically P is when you take G and shift it 1 unit to the right. Okay, all right, because P sorry. So x minus 1 means G has been shifted 1 unit to the right, not left, right. Okay, and so far the coordinate of P is 1 and negative 9 over 4. So if we move it 1 unit to the right, it won't be 1 anymore, but it will be 2. So they're asking the equation of the vertical asymptote. So basically, let me just write there, shift 1 unit to the right. Therefore now x will be equal to 2. Okay, cool. That is 4.3, 1 mark. 4.4. Determine the equation of the axis of symmetry of G in the form y is equal to mx plus c. So let me just redraw. I used to be able to edit PDFs, but now it's a little bit, it doesn't work anymore. Okay, so we have our okay, and then we have our asymptotes. You can pretty much fast forward through this. And that would be 2 and that would be 1. So this coordinate here, this point of intersection is 1 and 2. Okay, then we have our function there. I'm just going to use a different color. We have G, yeah? And this, it passes through the origin. What did I do? Ooh-wee. I just wanted to shift that. Okay, pass through the origin. And now what are they wanting? They want the equation of the axis of symmetry. When they ask that, guys, it's basically the axis of symmetry. You have 2 of them, okay? One has a negative gradient. The other has a positive gradient, okay? And the gradients are always either 1 or -1, depending on the positive or the negative. So basically this would be y is equal to x, because it's a positive gradient, x plus c. So you just need to work out what c is. C1, and this one would be y is equal to negative x plus c2. Negative x because the gradient is -1. It's going down the slope. and C2 because obviously it passes, this would be C2 and this would be C1. So I can't just say C for both of them. The C's are different. So now which one are they looking for? So they are looking for the one where the gradient is smaller than 0. So we are looking for this equation. Okay. Now along this line, for you to calculate, or rather to determine the equation of a line, you need the gradient and you need at least 1 point. So we know that the gradient okay, we know that the gradient is -1 and we have a point, remember, where the asymptotes actually intersect. That's also a point on the lines of the axis of symmetry. So that point that we have is actually 1 and 2. And because you have a gradient and you have a point, you can calculate the equation of the axis of symmetry. So y is equal to mx plus c. So in the place of y, we put 2. In the place of m, we put -1. In the place of x, we put 1. And now we can solve for c. So c would be 2 plus 1. And c is 3. Does that make sense? Yes. C makes sense because it's above 2. Okay. So basically there's the 3. So the equation would be y is equal to -x plus 3. Okay. That is 2 marks. They expect you to know this by now. You've been doing it since grade 11. Okay, so 4.5. Now it says, write down the equation of k. If k is the reflection of g about the x-axis. So at least I drew g. Okay. A reflection about the x-axis. Let me do a simple, or just draw a simple graph, because this one can get a little bit complicated if you don't pay attention. So this is your x and y axis. If I had a graph like this and I had to reflect it about the x-axis, you agree, right, that it would do this? Because about the x-axis, if I close it up, it should fit. Okay. So what happened to the x value? Let's say this is 3 and that's 4. Okay. So do you see that? Okay, let me use a point here. Let's say it's -3 and 3. Okay, if I take this point here, do you see that the x value remains the same? But what happened to the y value? It changed, it became negative. So here I would have -3 and -3. Okay, this would be -4. So that is what happens when you reflect about the x-axis. Your y value becomes negative. So if they ask you now, write down the equation of k. If k is a reflection of g about the x-axis, firstly the sketch would look something like this. I mean, this is not necessary. This is me just explaining above and beyond. If I were to reflect this about the x-axis, first of all, I would need a new asymptote, which is -2. Okay, the 1 stays the same. Okay, so I would then have a graph looking like this. What I'm drawing now is k. And the other portion would, so if I started there and I'm bound by, it would do, it has to pass through the origin. But no. It would do this. This is how k would look. But they don't want us to sketch k. They just said, what is the equation for k? Okay, so let's go back to g. If g was 2 over x minus 1 plus 2. K would be equal to negative 2 over x minus 1 plus 2. And again, why negative 2? So if you have your, please have a look at our video where I discuss functions, particularly the hyperbolic function. So the purple one is the original, that's g. You can see a was positive, which was 2. Okay, and from left to right, the graph went like this. But for k, the red graph, from left to right, it went down. So it makes sense that 2 should be a negative. And that's where you apply the negative. Okay, and that's the equation. Or you could have put a negative here. Okay. Let me just do it like this. You could have said, because the y has to be negative, it would have been something like this. I'm glad I did that. So I have negative 2 x minus 1, and I also have a negative 2 there. I forgot about that negative 2. Yes, so please put brackets. Please. Okay, so that is what? 2 marks again? Yep. 4.6. For which values of x is, now you know when you have that little apostrophe there, it means when you basically, it's there by that topic, but again, differentiation, when you differentiate, yes, I forgot the topic's name. Calculus, yes. Okay, so basically if you took your function, f, okay, and you basically differentiate it. So f is a quadratic function. If you differentiate, you're going to get a straight function. Again, go through the notes or the video where I discuss cubic functions, because if you have a cubic function, okay, and you differentiate it, you're going to have a parabola. And if you differentiate it, you're going to have a straight line. Okay, so I discuss all of that. So when they say f prime, they're basically referring to a straight line. Okay, so what is that f prime? Let's go look for it. How many marks? 2 marks. Yo, I'm doing a lot for 2 marks. So f of x, we wrote it somewhere. So it will be x minus 1 plus, or minus, yeah, so f minus 9 over 4. And if we calculate it or take out the brackets, we have x squared minus 2x plus 1 minus 9 over 4. And if we differentiate it in terms of x, we're basically going to get 2x minus 2. So basically this is our function, okay? And if I were to draw it here, this graph is busy. Let me remove k. Okay. Okay. Let me just draw another one. Let me pause, draw, and then we'll discuss. Okay, so I've drawn it. I think it's better presented when it's drawn. If you want to calculate, by all means, you're welcome. You would just say 2x minus 2 times the hyperbolic equation, and then just look for values bigger than 0. I prefer a sketch, and it's only 2 marks. So I feel like, yes, I'm doing a lot for 2 marks. But as long as you understand, if you have a shorter way of doing it, you can comment down below and help others, okay, who want to just get it over and done with. So if f prime times g is bigger than 0, just bigger than 0, not equal to 0, what should f and g, what values should f and g have? Well, basically, negative values for g and negative values for f prime will give me a value higher than 0. Positive values for g, positive values for f prime will give me positive. So if I look at G here, I have positive values, right? Until I reach 0. Here I have negative values, so that will not work. Okay, I have negative, but where they intersect, because in this region, after we pass the y-axis, do you see that they are both negative here? Okay, negative and negative. So from this region here, up until we get to 0 for f prime, that's where the values are applicable. So I would then first start by saying x has to be bigger than minus 2, has to be bigger than 0, okay, because we're on the y-axis. So yeah, x has to be bigger than 0, but it has to be smaller than 1, okay? So this is the first region that we are working with, okay, where both are negative and they yield a value bigger than 0. So now after 1, what happens? Well, f prime is positive, and also g is positive. Okay, so again, where x is bigger than 1, not 0, sorry, yes, where x is bigger than 1, not bigger and equal to, because we would have 0, okay? So x is bigger than 1, and where does it end? Well, it ends in infinity. So that's how I would write the answer. Or you could have said x is an element of 0, 1. Then you put a union sign. And then remember, around infinity, you always have round brackets because you don't know what infinity is. Okay, 4.7. For which values of k will the equation g of x is equal to x plus k have two real roots of opposite signs? Okay, this question is a bit confusing because g of x is the hyperbola, okay? And the hyperbola cannot really have, well, this one in particular, it cannot really have two real roots of opposite signs. So what that means is, if you have your hyperbola, you have your vertical, so you have this part and that part of the hyperbola, right? Ugly sketch. But if I shift it up or down, there will never be a point where both these portions of the hyperbola are going to touch the x-axis. Currently, only this one touches, okay, both the x and y. If I keep lowering this graph, maybe this might do that, so it touches, but this will still not touch. And by the time this one touches, this one now wouldn't be touching. If that makes sense. So the hyperbola can't really have, it can't have two real roots of opposite signs, can either have one. But then the question itself is not referring to the hyperbola. It says g of x is equal to x plus k. Like, what happened to the hyperbola now? Okay, x plus k, if we say gx equal to x, that is like a straight line, okay? And again, a straight line, so k is a vertical movement. Let's just start there. A straight line, whether you move it up or down, let's see. A straight line will only touch the x-axis once. So if I keep moving it up, it's touching now the negative side. If I move it down, it's touching the positive side. So you can't have, unless if I'm missing something, guys, this question, and it's only 1 mark. It's a mark I'm willing to sacrifice. Shall we move on? So the only thing that I can think of that will have two real roots of opposite signs, that would be f. Let's see. Yeah, g is the hyperbola, f is the parabola. So f is the only one to me that makes sense, that can have two real roots that are opposite in sign. I mean, exactly as it is right now, you have a real root which is negative and a real root which is positive. So maybe it's me, but I feel like they should have used f of x. I don't know. I don't know. Let's park this one. Once I figure it out, I'll put it in the comment section. Yeah. And we'll end it here. For now, I'll put it in the comment section. Let me go think about it, okay? Thank you. Doesn't want to pause. Hello everyone and welcome back to NB Tutors. You're still with me and we're going to tackle question 5. So it says the graph of h of x is equal to a to the power x. It is an exponential function. Yes, where a is bigger than 0, most definitely. And then we have p somewhere along the graph, point p, and yeah. And q looks like it is the y-intercept. Okay, so let us answer the questions. So 5.1, which is 1 mark, it says write down the coordinates of q. So guys, if you have a normal exponential function, by normal I mean you don't have a vertical or horizontal shift, okay, or there isn't a factor applied in front of a, then your graph will always pass y or the y-axis at 1, right? Because their x is 0 and you know anything to the power 0 is 1. So that's why it's only 1 mark. Okay, so q will be 0, 1. But if there was a number in front of a, you would basically multiply 1 by that number. If there was a horizontal shift, then yeah, this doesn't apply anymore. Okay, now it says determine the value of a. Okay, so we have our function. I'm just going to put it in terms of y instead of h. So y is equal to a to the power x. They gave us a point. Please use that point, okay? The y coordinate of p is a half. And then the x coordinate of p is -1. Okay, so basically I have 1 over 2 and a to the -1 is the same as 1 over a. So basically a is equal to 2. All right, then we can go to 5.3. It says write down the equation of 4h, basically the inverse of h. Okay, so we know that h is basically 2 to the power x, which is like saying y is equal to 2 to the power x. Now what would be the inverse of h? Okay, so the inverse meaning we just swap x and y around. So now we have x is equal to 2 to the power y. And if you've been doing logs for quite a while, you can see that your answer will just be y is equal to log base 2x. If you don't know how to just see it like that, you can basically say, okay, you're going to apply log to both of them. Okay, you know when you have a power, you can take it down. Sorry, an exponent, you can take it down. So you have log 2, log x, and if you want y alone, it's basically going to be log x divided by log 2, and that would then be log base 2x. That's a very long way of working it out, but if you understand it, then great. Okay, and that was like what, 2 marks? Yeah. So now 5.4 says sketch the graph of the inverse. Okay, clearly showing all intercepts with the axis. Okay, let me try to draw it quickly. If I see that I'm taking time, then I will draw it. I will pause, but anyway, I'm already there. So this is what h is. Okay, so how do we get the inverse of h? Well, basically you're gonna draw your line y is equal to x. Okay, and then your inverse is always symmetrical about the line y is equal to x. So your answer should look something like this. Okay, yeah, at least that didn't take time. So basically, this was h, right? And h, we know it passes the point 0, 1. Okay? When you look at your inverse, okay, it will pass there 1 and 0. Okay, and your y-axis will act as your asymptote there. Okay, whereas for your normal function, your x-axis will act as your asymptote. So I think we've indicated everything. And remember, this is your line, y is equal to x. Okay, and that's it. And this is probably what, 2 marks? Yeah. So 5.5, write down the domain of the inverse of h. Okay, so domain, basically all the x values. So as you can see, x cannot touch 0. Basically, it can't touch the y-axis because the y-axis is acting as an asymptote. So your graph, the values of x start higher than 0, okay? And then where do they go? They go all the way to infinity, basically. Okay, or you could have said x is an element of 0 and infinity with round brackets. Okay, and that's 1 mark. Makes sense. 5.6, hence or otherwise, determine the values of x for which log base 2x is bigger than 1. Okay, so basically, this is where 1 is. Okay. Okay, so this is where 1 is. No? The y value of 1. Let me just shift it a bit. Okay, so they are saying determine the values of x, okay, for where your graph, the inverse of h, is basically bigger than 1. Okay, so you do know and you can see here that this value can go on. It can go on and on and on. So you want to see what is this x value here where basically this function can be bigger than 1. Okay, so I say it's only 1 mark, and I don't know if it really is that obvious. For me it isn't. Okay, so bear with me. I will solve it. I mean, in a test situation, I would definitely solve it. Even if it's 1 mark, because guys, I can't see it. And if you can, please comment down below. Just tell me, Tsolo, come on, it's straightforward. It's what. For me, I can't see it. I need to go solve. Okay, and this is how I solve. Let me just pause, solve it, and then we'll discuss, because 1 mark, I don't want to take up a lot of your time. Okay, now that I've solved it, I see why it's 1 mark. Okay, so I do see that that's where x is bigger than 2. So this value here would be 2. So from 2 onwards, the graph is bigger than 1. But yeah, I solved it, okay? And yeah, I wouldn't have seen it just in J. But yeah, it was good to solve. Alright, now 5.7, it says, if g of x is 1,000 times 3 to the x, calculate the value of x for which h of x is equal to g of x. Oh, I thought it's also going to be 1 mark. And I'm like, oh my goodness, I cannot do without solving. So we are going to solve. So h of x, we know, what was it again? It's 2 to the power x, ne? Yes, 2 to the power x. Okay, h to the power x, we know that it's 2 to the power x. And then g, they told us it is 100 times 3 to the power x. Okay, So how do we solve for x? Calculate the value of x. All right, so what I'm going to do here, I'm going to put logs. Yes, I will be applying logs. All right. So I have, no man, should I be applying logs? No, I'm not gonna apply logs because that's just gonna make x cancel itself. What I will do, I know I have the same exponent, so I'm gonna divide by 3 to the x on both sides so that I'm left with 100. Okay. By the way, how will these functions look? I mean, 2 to the power x and 3 to the power x are not so different, right? It's just a matter of which one is steeper. But if you put that 100 there, it makes a huge difference. Hence, yeah, where will your values be the same? I don't think it would be the same on this side. The other one is probably going to do something like that. So they will probably meet somewhere here. Okay, but yes, so I have 2 over 3 to the power x, and I have 100. And only now I think I can use logs, not previously. So I would have base. Okay, so I would say, why am I confusing myself? I don't know, but I would say x log 2 over 3, let me not confuse myself, and log 100. Okay, so basically x is equal to log base 2 over 3, 2 over 300. Okay, yeah, I confused myself here. So basically x would be the answer, this would be the base, and the 100 would be there. And now we're gonna definitely use the calculator. So log 2 over 3 100, and it's in negative 11,36. Yeah, so that's basically the value of x. All right, thank you for joining me for question 5. I will see you next time or not. But yeah, I hope the preparations for paper 2 are going well, and I hope this doesn't distract you from preparing for paper 2.
Well, welcome to MV Tutors. Wow, what a good day it is. The birds are chirping, the sun is shining, the sky is blue, and we're having a good time right here. So, we are doing this paper. This paper was just written yesterday, so we are literally doing this memo without actually receiving the actual memo. So, this is just us doing, the best answers that we think are in the memo. Okay, but so that means that if there is any mistake, please do put it down on the comment section. We are open to being corrected. Okay, other than that, we're doing question number 7 now, and it's financial maths. It's a very, very practical section, this one. I often ask my students, is financial maths mathematics or not? Just like statistics. Is statistics mathematics or not? And then we get a debate going. Some say yes, some say no, with various reasons. But without any further ado, let's get right into this particular question. Okay, it says, at what annual percentage rate compounded quarterly should a lump sum be invested in order for it to double in 6 years? All right, now I know that you get forex traders there saying, I'm going to double your money in 2 months. You can actually calculate for yourself what interest rate that is. Okay, assuming it's compounding, that investment or that trade. But here we are, we just want to double in 6 years, and that's it. So how are we going to do that? The first thing to do with financial maths that's very important is to pick the right formula. Now, what's the formula for this one? Okay, now if we just write this thing down, okay, we're doing question 7.1, and the formula is the compound one. Okay, that's our clue. So it's gonna be A is equals to P, okay, and then 1 plus I in there, and then the N is on top. That's compound. Okay, so now what I like to do is just write my variables on the side, to say what is my A, what is my P, what is my I, and what is my N. Okay, let me just make sure the I looks like an I. Okay, now let's go back and read the question. At what annual percentage interest rate? So it looks like we're looking for the interest rate. Okay, so we're just gonna put a question mark there. And you know what? The interest rate is actually compounded quarterly. So what does that mean? That means we divide the interest rate by 4, okay, and then we multiply the number of years by 4, okay, and then should a lump sum be invested in order for it to double in 6 years? So the number of years is 6 years, and then between P and A, we know that the principal, let's just call it P, and then A, that's the tricky part right there. Now, what is A? A should be 2, okay, it should be 2P, just like that, because remember a double is twice the principal amount. So, okay, there we go. Now, all we have to do is just substitute this back into the equation. So, where there's A, I'm going to put 2P. And then where there's P, I'm going to leave it as P. And then I'm going to have 1 plus I divided by 4. Okay. And let me just say 4 times 6. I don't know what that is, so let me leave it as 4 times 6, probably 24, but it's fine. Okay, so what's gonna happen now? I'm just gonna get rid of like terms, divide everything by P. Okay, let me show you that step before you say I skipped steps. And then this side, I'll be left with 2 is equals to 1 plus I divided by 4 to the power 24. Okay, what's gonna happen now? Right, if we want to solve for I. Now, I like to use my logarithm, okay? But that's let me put it this way. Logarithms are useful and in such questions, especially if you're gonna solve for the number of years. But if you have a sum such as this, when you want to get rid of the exponent, what I can do is I can multiply by an exponent on both sides. Okay, and it's gonna be 1 over 24, just like that. Okay, and what I do on one side, I should do on the other side, 1 over 24, just like that. Okay, so now what that helps me to do is that now I'm gonna have a situation where it's 1 over 24 as an exponent, and that's gonna be equals to 1 plus I over 4. Okay, just like that. I hope you can follow. And then from there, we're just gonna simply subtract a 1 from there. 1 over 24 minus 1, and then we have I. And what I want to do at this point is multiply both sides by 4, so that I can put this in brackets and put a 4 right there. Ladies and gentlemen, I am ready for my calculator now, so I'm just going to bring it up. Calculator, come on up, sir, please. And the sum that I want to put is, let's do it. Oh, you can see it. Here we go. So I want to put 4. Let's put 4, and then open a bracket. We put 2 to the power 1. I'm just going to put it in brackets. I'll put 1 divided by 24. How about that? Okay, you are allowed to do that. And then I'll put a minus 1 down there. Close the bracket. Okay, and what is that? We get that I is 0. Let me just start with the I this time. I is equals to 0.1172. Now, whenever you're dealing with financial maths, especially interests and stuff, you want to have 2 decimal places where you're doing percentage. Otherwise 4 if it's a decimal, because now what I'm going to do is just convert this to a percentage by doing what? Multiplying by 100, and then I get I is actually 11.72%, just like that. That's it. That's what does this mean? For our investment to double within 6 years, we need an interest rate of 11.72%, compounded quarterly. All right. Okay. So let's just go see now the next question. It says 7.2. Simon buys furniture for the value of 10,000. He borrows the money on the 1st of February 2020 from a financial institution that charges interest at a rate of 9.5% per annum, compounded monthly. He agrees to pay monthly installments of 450. The agreement of the loan allows him to pay equal monthly installments from the 1st of August 2020. Okay, thank you. Let's see what's going on here, Simon. Okay, so now it says calculate the total amount owing to the financial institution on the 1st of July. Okay, so first of all, what I want us to deal with here is actually what is, so I just wanted to change my color. We are now dealing with 7.2.1. Okay, so calculate total amount owing financial institution the first. So look at this. If we have a timeline, okay, so he borrows the money in February, right? So let's just put a little Feb there. Man, this tablet, I'm not used to using. It's my first time using this tablet and it's not working out very well. Okay, so that's February. He borrows the money, so he is supposed to start paying on the next month, which is February, March, April, May, June, July. So it says here calculate the amount owing to the financial institution on the 1st of July. So let's count now how many payments he was supposed to make. So it's one, 2, 3, 4, 5. Okay, just let me pause there. Alright. Okay, let's continue. I just had a little disturbance there. We said it is 5 to the 1st of July. So this is July. Damn this pen, this tablet. Okay, so that's July right there. And okay, so we know our months is 5 payments. Calculate the amount owing. So first of all, we need to get the right equation, and the equation once again is compounded. It's a let's put a p and then open the brackets. 1 plus I to the power n. Okay, now variables, once again I'm just gonna skip that part and just go into substituting them. So p, we know p is 10,000. Okay, and then that's 1 plus, and the interest that we're given is 9% compounded, 9.5. So really that's just 0.095. Don't forget this 0 after the decimal, it's very important. Divide by 12 because it's compounded monthly. And then the n, then we've counted it that it is simply just 5 payments. Okay, so we're not going to multiply it by 12 because remember the reason we normally multiply n by 12 is because that n is often given per annum. It's often number of years. Okay, so it's already converted to months here, so we can choose. So I'll put this in a calculator. So we will have 10,000, right? And then open the brackets. We put 1 plus 0.09. What did I do? 0.095. Close that, and that should be to the power of 5, like that. And what do we get? Is that so? Ooh, I must have done. Oh, yep. Classic mistake. You know, my mistake is that I did not put. Let's start again. Okay, so it's 10,000. Just like that. Open the bracket, and then it's 1 plus 0.095 divided by 12. Close the bracket, and it should be to the power of 5. And there we go. We get 10, 4, 0, 2 point. This is money, so 1, 5. Don't forget to put the units. This is in rands. Okay, that's in rands. Alright, that's the amount. Thank you, calculator. Let's move on. Now it says, how many months will it take Simon to repay the loan? Ooh, now we're solving the number of months now. Okay, so it's very important to get the right equation once again, and the equation really that we will be dealing with here is this one, the annuity equation, where we have a is equals to x. Okay, and then we got square bracket, and then it's 1 minus 1 plus I, close the brackets, to the power minus n, and and then square bracket, and all of this divided by I, just like that. Okay, let me just substitute at this point. Our A, this is the amount he owes. Take to how many months will it take Simon to repay the loan? Remember now, if he's starting on the 1st of August to pay, that means the amount that he's gonna pay is 10,402. Why is that? It's because this formula assumes that you're gonna, if you take a loan on this month, on the month of, like he did, if he takes the loan on the month of February, he is supposed to start paying beginning of the month of March, which is the following one. And in the month of February, he owes 10,000 rand. But now, if you look now, in the 1st of July, he no longer owes 10,000. He owes 10,402. And he's gonna start paying that amount on the 1st of August. Okay, and so that is why now that our A value is going to be 10402.15. Okay, just make sure you understand that. And X, we are told that he will be paying in installments of 450. Okay, let's put that. And then what do we else? 1 minus 1 plus, what is our I? Interest is still that 9% compounded. Now it's 0.095 divided by 12, and all of this should be to the power of minus n, because that's what we're dealing with. Same thing here, interest is going to be 0.095 divided by 12. Okay, so all we have to do now is just some mathematical gymnastics, really. So we just take this there and divide by that, and so let's try to do this systematically. So what I'm gonna do for you is that I'm just gonna write down 10402.15. If we get rid of the, so we start with the fraction, so we'll multiply that with 0.095 divided by 12, and then we're going to divide it by this 450. Okay, so divide this whole thing by 450, and that's going to be equals to 1 minus, we just got rid of the square bracket, 1 minus 1 plus, that's 0.095 divided by 12 to the power minus n. That's what we want. So we can just simply take this one to the other side, but let's bring out a calculator at this point, okay, before we get too deep, right? So what you want to do is put on your fraction first, and then put that 10402.15. Open that bracket, and then I got 0.095 divided by 12. Close that bracket. Anything else? No. And then we can go downstairs. Why did I square it? It doesn't need to be squared. Let's delete that square, and then we can go downstairs. Then we put 450. Okay, just like that. All right, and that's gonna give us an answer. Let's just, ooh, there was a problem. Let's start again. 104.02.15, open the bracket, 0.095 divided by 12, close the bracket, go downstairs, and we put 450, and then we'll get that answer. And then what I want to do at this point is just go ahead and subtract 1, because you see I'm subtracting 1 on both sides. And then so I'm gonna take that answer and say no, not there. Let's say equals first, or maybe let's just, for consistency's sake, let's just say 0.18. Okay, you're not supposed to round off during working out. Okay, and then I'm gonna say minus 1, that's gonna be equals to that bracket, and this bracket is also going to be negative. 1 plus 0.095 divided by 12. Okay, minus n. Oh man, I hate this tablet, but anyway, let's work with it. Okay, so let me just do that and say the answer minus 1, and then I get minus 0.82. I'm rounding off. Okay, that's equals to, that's this whole thing. Okay, I don't want to rewrite it. So what I'm gonna do now is that, okay, let me rewrite it so that it looks much more clearer. 0.95 divided by 12 to the power minus n. Okay, so now what can we do at this stage? If we want to solve for n, you need to remember your properties for logs. Remember, if I want to solve minus n, that's gonna be equals to the log of, at the base stays the same, so the base is still going to be this thing, 1 plus 0.095 divided by 12. I could have put that in a calculator, but I'm going to have too many answers. And then on top here, then I'm going to have minus 0.82. Okay, but when it comes to my calculator, what I'm gonna do is that I'm gonna say the log of down there, then I'll put that in a bracket, which is 1 plus 0.095 divided by 12, close that, and then I come to the side over there. What was my answer? Ooh, it's 0. So that's not the answer I want. I want to put that one, which is minus 0.82. Now, it's not very accurate because obviously I rounded off and I'm not supposed to, but it'll give you a clear idea. Okay, so we get minus 25 and some change, so minus 25.2. It's not really accurate, this 0.2. It would have been more accurate if I had put this and got the actual answer for it, this 0.82. It could have been more accurate if I used the whole number, which was 0.81 blah 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 16, that one. But anyway, we have an idea now, or we can drop both negatives, then therefore we can say the number then that we are looking for you can never have 25 payments. What this means is that you have 25 full payments plus 0.2 of a full payment. Okay, so this is actually, we're gonna say this is 26 payments that he has to make, because that was the question, right? How many months will it take Simon to repay the loan? It will take him 26 months. If they said how many full payments will he make, that would have been, then the answer would have been 25 full payments. But because they're asking just payments, it's gonna be then 26. I hope that's clear. Now let's go to the last question, 7.2.3. Okay, what is the balance of the loan immediately after Simon has made the 25th payment? You see, now they are asking what is that 0.2%. Okay, but the way you calculate it is not just taking 0.2 of, the final amount. No, you need to know the balance outstanding, a formula. So the outstanding balance formula is such that you have, really, it's just a minus the future value. Okay, what do I mean? A is going to be P 1 plus I to the power n minus the future value formula, that's that one, that x, and then 1 plus I to the power n, and then you got minus 1 there, and all of this is divided by I, just like that. Okay, let's put in some values at this point. I'm gonna start here because not everything might fit. So P is that 104, what was it, 104 02.15, and then we've got that 1 plus the interest that we were given here is still the same interest. It's not going to change. It's still going to be 0.095 divided by, it's compounded monthly, so divide by 12. And this, how many months is this going to be? This is still going to be the 25 months that we have been given. Okay, so we'll put the 25 minus that x is still going to be the 450. Okay, and over there, it's going to be long. We're still going to have 1 plus that 0.095 divided by 12. Close that to the power 25 and minus 1. Then we close it. I is still 0.095 divided by 12. Okay, let's go ahead and put this in a calculator then. So this is now going to be 10402.15. Open the bracket, 1 plus 0.095 divide by 12, close that. That's to the power of 25. Come downstairs, subtract now. Let's put the fraction. We've got 450 there. Open the bracket twice. Okay. 1 plus that's 0.095 divided by 12. Close that bracket, that second bracket, to the power of 25. No, 25. We come downstairs, subtract 1, close that bracket. Okay, and then we come downstairs again, 0.095 divided by 12. And what do we have here? We have that our final amount, that 0.2 is comes down to 282 point, because it's money, 2 decimal places, 36 cents. Okay, so that's the outstanding balance right there. Well, that's it. This was a challenging question for financial maths, but I hope you understood everything we did. I really did try to go as slow as I could, and that's it. Well, thank you so much. I appreciate you.
Hello everyone and welcome back to MV Tutors. I'm Solo and we'll be looking at question 8 together. Calculus. Okay, so let's see. You know this question is going to come up where you have to determine from first principles 3x squared plus 2x. Okay, it won't be 3x squared plus 2x all the time, but first principle questions, definitely. Please don't mind the noise in the background. Alright, so basically this is how the answer would go. Please do not forget this limit as h tends to 0. Okay, and then what do we have? We would have fx plus h minus f of x. Okay, and that's all over h. Okay, I'm gonna start it here so that I have space. Okay, so I will be taking the equation, and in the place of x we substitute x plus h. So we have 3x plus h squared plus 2x plus h. This can be quite laborious. Like, why do we have to do this? Surely you know we can do this. We found the easier way. Why are you punishing us through this long way? Okay, so the limit as h tends to 0. So if we multiply that out, we'll get x squared plus 2xh plus h squared. If we multiply that out, 2x plus 2h minus 3x squared minus 2x, and that will be all over h. Okay, and then we have our limit there as h tends to 0. So we multiply out and we have 3x squared plus 6xh plus 3h squared. Okay, we can actually cancel out this 2x and negative 2x, so we have plus 2h minus 3x squared, and that is all over h. Okay, so we have our limit as h tends to 0. We can cancel out the 3x squared, and we can actually take out h as a common factor, right? Yes, we can. So we have 6x plus 3h plus 2 all over h, and the h's cancel, so we are left, please do not forget that limit as h tends to 0. You might lose marks. So the h's cancel, and we are left with 6x plus 2 plus 3h. I can already, we know that we're expecting 6x plus 2. If by this time you're not seeing 6x plus 2, you know something is wrong. So when we then put 0 in the place of h, this term cancels out, and then we don't have to write limit as h tends to 0. Again, we can just write down the answer, which is 6x plus 2. Okay, then we are done. Now we get to determining dy dx if we have y in that form. So y, I'm just gonna write it in a form that will be workable from now, ne? So we have 4. Root x is the same as x to the power a half. Okay, and then minus 8 over root x. So basically that is x to the power negative a half, plus pi x cubed. Okay, so now I can do dy dx, differentiate. Okay, differentiate y in terms of x. So what do? We take the exponent, we multiply it by the coefficient, and then we subtract 1 from the exponent. So this is what I mean. Take half times 4, that's 2. Then we have half minus 1, which is negative a half. Okay, and you put it like this so that it shows that it's actually an exponent. And then we say negative a half times negative 8, which will be positive 4. Okay, and then x, so negative a half minus 1, that's negative 1.5, which is negative 3 over 2. Okay, so we're done with the second one. How many marks is this? 4. Okay, and then we have 3 times pi. I'm just gonna say 3 pi. If you want to go and calculate 3,14 what times 3, by all means do that, but I don't think it's necessary. So 3 pi will be as it is, and then x to the power 3 minus 1, which is 2. So I would end it here. I don't think it's necessary to bring back the square roots, but if you want to bring them back, basically that will be 2 over root x, and then that will be plus 4 over x to the power 2. We have 3 there, and then we have 3 pi x squared. Okay, so that's 8.2. Now we can do 8.3. It says the graph of g of x is equal to 8x squared plus b over x is equal to 96. Yeah? So we have a parabola, a quadratic function, where the y value is equal to 96. Okay, and then it has a minimum value at x is equal to 4. Whenever you have a quadratic function and they talk about minimum, or even quadratic sequence, not series, if they talk about minimum value and maximum value, they're talking about the turning points. So if it's a smiley face parabola, it will be a minimum value. If it's a sad face parabola, it will be a maximum. Okay. So yes, we have a minimum value at x is equal to 4. So we know our turning point has an x coordinate of 4. Now it says calculate the values of a and b. Okay, how will I best do this? How many marks is, 6 marks. Okay, so our function is equal to ax squared plus, what? No, this is not a parabola. We have b over x. Okay, so whoa, not a parabola, sorry. Only the ax squared part is a parabola, but b over x is a hyperbola. My goodness. Okay, so it's equal to 96 and has a minimum value at x is equal to 4. Again, if you want to get minimum maximum values, please determine the first derivative. Forget about the whole parabola story. I did not see. I thought it's bx. So basically what we're going to do, we know that g of x at this case is equal to 96, okay? And they gave us that the minimum value at x is equal to 4. So we're going to determine the first derivative, okay? So actually, let me just rewrite this as ax squared plus b to the power negative 1x. Okay, so g of x, or rather the first derivative, I would get 2a x, because 2 minus 1 is 1, so it's x to the power 1. And then we have negative b x negative 2, and that would be equal to 0. And then we know that it has a minimum value at x is equal to 4. So I'm going to substitute 4 minus b, 4 to the power negative 2 is equal to 0. So I have 8a. 4 to the power negative 2 is the same as 1 over 4 squared. So I have minus b over, I just thought of something, but anyway, I have negative b over 16. So I can multiply everything by 16. Let's just see, what is 8 times 16? (128a) minus b is equal to 0. Calculate the values of a and b. Okay, our second equation, well, we would still take that x value 4 and make it equal to 96. That first, so basically g4 would be equal to a 4 squared plus b over 4, and would make that equal to 96. So if I multiply everything by 4, I get 4 to the power 3 times a, and then I would get 4. What is 96 times 4? 384. Okay, let me simplify it further. 4 to the power 3, I think that's 64. Okay, so this is my first equation, and that is my second equation. So I will be taking the first equation, 128a minus b is equal to 0, and then 64a plus b, 384, and I'm going to add the 2. (64 plus 128 is 192. 192 is equal to 384. So 384, this is what we are working for. Those 6 marks, 384 divided by 192, it's 2. So a is equal to 2. And then b, I can just say 128 times 2 is equal to b. So b is equal to 2. Let me just calculate. Because I saw the 8 and I'm like, nope, let me not do that. So 256. Okay. And that is it for question 8. Hello everyone, welcome back to MV Tutors. I'm Tolo and I'll be looking at question 9 with you guys. We're almost there. We are. We are almost there. So, question 9, cubic function. Again, if you are struggling, please go to the video where we discuss cubic functions. Okay. So yeah, question 9. We have the graph of h of x. So it's minus x cubed. And yes, I can believe it. Remember with when a is a negative value, your cubic function ends with a sad face. If a is a positive value, your cubic function ends with a happy face. Okay, so yeah, h of x is equal to negative x cubed plus ax squared plus bx plus c, and it's sketched below. A and b are the turning points. They've given us the coordinates of b. Great. T is a point on the function h, and graph h passes through the origin. So we have all the x-intercepts. Basically it's 0, 6 and 6, because you know at a turning point you have two values there. Now 9.1, it says show that a is 12 and b is 36, and this is 3 marks. Okay, so 9.1, so we're going to take the function h of x is equal to negative x cubed plus ax squared plus bx plus c. Okay, we have a point, or we have 2 points that we know of. We have a point at the origin, which we're not going to use because we're just going to be left with c is equal to 0. I guess it helps. We know the y-intercept, c is equal to 0. And then we have another point that they gave us, which is b. Okay, and that is the x-intercept. All right, we're not going to use t because we don't know what y is, so I'm going to put b as a point. Okay, so we have h where x is 6, so negative 6 to the power 3 plus a 6 squared plus b 6 plus 0. And we know that this is 0. So 6 cubed, I don't know what it is. Should I know? No, we have a calculator. 216. Negative 216 plus 36a plus 6b. So basically 36a plus 6b is equal to 216, and that is our first equation. So we need to go get another equation, and what we're going to do is get the first derivative. So that'll be negative 3x squared plus 2ax plus b, and we know that is equal to 0, right? And because we had a turning point at b, we can still use coordinate b. Okay, where we know that, actually, we can just leave that out, and we can just say negative 3 times 6 squared. Okay, and that will be equal to 0, because the gradient at a turning point is 0. Remember, this is a gradient. So now 36 times 3 is 108. So negative 108 plus 12a plus b is 0. So 12a plus b is 108, and that is equation 2. Okay, so what are we going to do? We are going to take the first equation. Okay, 36a, you could solve it differently. I just find it easier to solve it this way. And then we're going to take 3 times the second equation. So 12 times 3 will give me 36. And then 3 times b, 108, I don't know what that is, times 3, 324. 324, and then we're going to subtract. Okay, so that's what I like doing. So 6 minus 3b, 6b minus 3b, that's 3b. And then 216 minus 324, that's negative 108. Okay, so b negative 36. And is that true? Yes, it is. Okay. Now we can use either equation. So I'm just going to say 12a plus b is 108. So 12a, 108 plus 36. A is equal to 108 plus 36 divided by 12. Okay, 108 plus 36 divided by 12. Ooh, by 12. So we get 12 as our answer, and yes, A is equal to 12. So I'm just going to write down the equation for future reference. So minus x cubed plus 12x squared minus 36x. Yeah, and that's it, because C is 0. Okay, cool. 3 marks. Yeah, we labored for this 3 marks. Okay, 9.2. Calculate the coordinates of A. The coordinates of A are the turning points, so we're going to get the first derivative, right? So that is negative 3x squared plus 24x minus 36, and that will be equal to 0. So if I divide by 3 or negative 3 throughout, I will have x squared minus 8x plus 12. Okay, what will give me 12 if I multiply, and give me 8 if I subtract or add? Six and 2. Yeah, if I subtract both, I get negative 8. If I multiply, I get positive 12. So x is equal to 2, or x is equal to 6. Okay, 6 we know it's b, so this can't be a, so this is a. But they want the coordinates of a, not just the y value of a. So we're going to take this 2 and we're going to substitute it in the original equation. So it's equal to negative 2 cubed plus 12 2 squared minus 36 2. Okay, yeah. And then we can put all of that in the calculator. So we have negative 8. Okay. Negative 2 to the 3 is 8 plus 12 times 4 minus 36 times 2. So we get it to be negative 32. So A is 2 and negative 32. Okay, it is a negative value, so yeah. And now 9.3. I was about to say, I wonder what the value the y value of t is. Okay, so yes, what is the y value of t? So what we're going to do, we're going to take the original equation and we are going to substitute t in it, because it's a point on the graph. And then do what with it? Okay, let's substitute. We have the equation there. So h of x, no, I'm not gonna repeat that. Let me just copy and paste it. Okay. Okay, so if we are going to substitute the point 3y, so in the place of h of x, we're going to put y, and in the place of x, we're going to put 3. So 3 to the power 3 plus 12 3 squared minus 36 3. And then we have negative 27 plus 12 times 9 minus 36 times 3. So we have negative 27. Okay, so therefore t is 3 and 27. And yeah, so a, it's weird though. I would expect t to be nearer to a. Yeah, but anyway, this is probably not drawn to scale, so we'll go with that. And then now 9.4. Right, negative 27. Okay, so is the graph of h concave up or concave down at point t? All right, seeing that t is so close to a, I would guess that it's concave down. But we need to show calculations. So for concavity, what do we look at? Basically, if you work out the second derivative, ne? And if you get that it's bigger than 0, then it means that it's concave up. But if your second derivative is less than 0, that means that it is concave down. So we need to go and look at the second derivative. Why am I using f? It's actually h. Okay, so basically the second derivative of h. So what was the first derivative of h? Let me just copy and paste it instead of trying to figure it out again. Okay, so yeah. Okay, so this is the first derivative of h. Okay, and then now we need to get the second derivative of h. So at point t, okay, so we will be substituting the value of 3 just to see, okay? So we have negative 6x, okay, and plus 24. Okay, so now let us substitute the value of 3. Look at me now putting x again. So negative 6 times 3. Okay, so we have negative 18 plus 24. And that's equal to 6. So it's not concave down. So we can see then that because the second derivative is bigger than 0, therefore it is concave up. Oh no! Yes, okay, the answer is concave up. What I meant was, because t is close to a and a is concave up, my assumption should have been concave up, not concave down. If t is close to b, then it should be concave down. Okay, so excuse me there, but at least we calculate, right? So that when our minds are thinking of many things, we don't make mistakes. Okay, we calculate to be sure. So it is concave up, and I believe it because in actual fact, t is much closer to a than it is to b. And a Yes, A is where it's flat, but after A and just before A, it is concave up. Okay, we're almost there. So now 9.5. Okay, determine the coordinates of the point of inflection. So let's see. Okay, we already determined the second derivative, which is basically negative 6x plus 24. And at the point of inflection, you make that value equal to 0. Okay, so then we need to solve for x. So I would say 6x is equal to 24. And then x, 24 divided by 6 is 4. So x is 4, right? And then we need to get the y value. So you're going to put it in the original equation, which is negative 4 cubed plus 12, 4 squared minus 36, 4. Okay, and then we're just going to work out what that value is. Minus 4 cubed plus 12 times 4 squared minus 36 times 4. And it is negative 16. So the point of inflection, let's just write it out. Point of inflection, but I guess you can put pi, 4 and negative 16. So therefore t, we just see it definitely was concave up. Okay, and we are done. How many marks? 2 marks. Yes, we are done with question 9. Thank you for tuning in. Don't forget to like our videos and subscribe to our channel. Bye.
Well, welcome to MV Tutors. My name is Figa and I am here now with question number 10. Now let me say something about question number 10. This is the hardest question I've ever had to do in my entire life. I struggled with this question, and it's one of those questions that you really leave out in the exam for the last thing you do if you still have time. But other than that, you skip this question, and I'm sure a lot of you did that. You skipped this question, but I finally, after much research and help from colleagues, I cracked it. Or rather, let me say, we cracked it. Okay. But in the way that we cracked it, this is not the only way that it can be done. There are other ways to do it. And please do drop down on the comment section on how you tackled this question. But without any further ado, let's get right into it. So it says a hotel has 72 rooms to let to clients. The daily rent per room is 500 rand. If the rent is increased by 100 rand per day, 2 rooms can be left vacant daily. Now, the first defense with such type questions is understanding what the English is actually saying. Okay, because if you don't understand the question, you will not answer the right thing. And that's what I battled with the most, because I was getting the concept wrong of understanding this question. But if you read it carefully, what it's really saying is that, okay, let's put the number of rooms right there. Let's just say number of rooms. Okay, let's put the number of rooms right there. So what it's saying is that, look at this. It says it starts off with 72 rooms. Okay, but what's happening? The daily rent per room is 500. Now, for 72 rooms, the amount that we're spending, let me just make another column here. I'll call it amount. Okay, amount, just like that. So for 72, what's happening is that each room is 500 rand. Now it says if the rent is increased by 100 rand per day, meaning that I'm increasing from 500 to 600. I thought it stopped there initially, but it actually continues to 700, to 800, to 900, and so on and so forth. Now it says if you increase by 100 rand per day, 2 rooms can be left vacant daily. So what does that mean? It means that the number of rooms decrease by 2 rooms daily. So from 72, it goes down to 70. It goes down to 68, right? It goes down to 66, such that 72 with 500, 70 goes with 6, 68 goes with 700, 66 with 800. Now, that's what these statements mean right here. The last part says the rent is X amount of rents per room per day, where X is greater than 500. So X is from 600 rand because it's greater than 500, from 600 and going down. Now, what I want to do then is that I really just want to multiply these values so that we can see how much the income is. Because remember, income is given by number of rooms times the amount. Okay, so if we read question 10.1, it says show that the total daily income is given by that. So the income here, let's start with the first one. Really, let's start with the first one. Let me move my calculator this side, and that first one is going to be 72. Okay, it's going to be 72 times 500, and we get 36,000. That's the income when we are given these conditions. It's 36,000, right? This pen. The next one is 70 times 600. What's the income there? It's 42,000. So we're just gonna go 42,000 like that. The next one is 68 times 700. So our income there is 47,600. Okay. The next one is 66 times 800. And we get 52,800. So now this relationship obviously continues all the way down. It's continuous. It doesn't really stop there. But what I want to bring your attention to, okay, is that now that we have actually established this this relationship, and then we can also see that the question gives income in a quadratic form. What's a quadratic form? Quadratic form is a x squared plus bx plus c. So now we can really start to manipulate this information that we have so that we can get this. And this formula gives us the total income. Okay, and remember what x is in this instance. X is the number, it is the amount of rents. Okay, as we can see from this question, is the amount of rents. So what we're going to do then is that, remember the amount of rents is this 600, 700, 800. So what we're going to do, we're going to look for the values for A, for B, and for C. We're going to solve for that. Okay, so we have three unknowns, and to solve three unknowns, we need three equations, right? Okay, so we're gonna, because we give in here that the rent is X rent per room, where X is greater than 500. So we're gonna start with X being 600, and what we're gonna do is that for A, we'll leave it as A, and then there we'll start with 600. We'll put 600 squared plus B. X is still 600, right, plus C, and that income, where X is 600, that income should be 42,000. Okay, just like that. Okay, let's get another one. A, we'll just continue. 700 squared plus B, 700, right, plus C is equals to, what's that one, where the income, where amount 700 is 47,600, like that. And then B, the last one, we'll have A, we'll put 800 there. Okay, squared plus B, 800, still X, plus C is equals to 52,800. It's just like that. Now we've got three unknowns, three equations. This is simultaneous equations. You can solve it. One way, the long way of solving it, is making C the subject of the formula, and then substitute it in equation number 2, and then you'll get B, and then substitute that B in equation number 3, and then you'll get A, and then substitute C again, and then you'll get, you in grade 12, you know how to do simultaneous equations. You can also use your calculator. Now, if you have a calculator like this, okay, this case here one, what you want to do is that you want to go to mode. So you'll go mode right there, and then number 5 is equations, right? So you'll press number 5 for equations, and then if you look down there, you want to pick number 2, because number 2 has A, B, C, and D being the I. So you pick number 2 like that, and then you put the information. Okay, so for A, you put 600 squared like that, and go equals, and then it will take you to B, and then you'll just put 600 equals, and then to C you put 1 equals, and then to D is 42,000, like that, 42, and then put equals. It brings you back. Now you must put the next one, which is 700 squared equals to 700 equals, C is still 1, and that's 47,600 equals, takes you back. The last one, 800 squared, okay, equals 800 equals, that's C still 1, and then it's 52,800 equals. All right, and then you press equals once. It gives you that the value of X, which is A, even though it gives you X there, it's A in this. So it gives you A is equals to -1/50. Okay, And then you press equals again, and it gives you y, which is b in this case. So b, and I got 82. And then equals, it gives you z, which is c, it's 0. That's it. That's it. That's how you do it. I do hope you saw that. I didn't want to use my calculator here, even though I can this digital one. It's just that you don't have this one, so I didn't want to confuse you too much. But you could also use any type of calculator that can actually do this. So now that I have these values, look at this. A is associated with x squared, so I know it's gonna be 1 over 50 x squared, plus b is associated, which is a, which is x, so it's 82 x, just like that. And then plus c, which is equals to 0. That gives us our income. Then I can conclude. Therefore, when I conclude, I want to rearrange this in the way that I have actually been given. So I is equals to 82 x minus x squared over 50. Okay, so like I said, we battled with this one, and shout out to Siobhan who came through with a better method. I just refined it a little bit so that I make it digestible for you, and that's how you do it basically. It's 10.1, but like I said, it's one of the questions you leave until last. Okay, there we go. All right, let's go to the next one then, which will be 10.2. It says calculate maximum daily income. Let me just switch off my phone, it's making a hell lot of noise. Calculate the maximum daily income per room. Okay, so that one, I'm sure all of you were pretty much happy with it, because you just remember whenever we're dealing with maximums or minimums, it's always a case of taking the first derivative, okay, of the income. So if we got the income is equals to 82 x minus x squared over 50, then the derivative of the income, I'll just put a little one there, it's gonna be just 82 minus, if I bring the 2 down, it's gonna be 2x over 50. Okay, simple derivative. What do we do with the derivative? We equate it to 0, and then we solve for x. So it's going to be 82 minus 2x over 50. Now we just have to do some mathematical gymnastics. Bring the 2x this side. I'm just gonna fast forward because I know I'm gonna have to multiply with 50, you guessed it, and then divide by 2. Okay, let's bring out our calculator. So we've got 82 times 50 divided by 2, and then we get 2050. 2050. There we go. 2050. Now this is the value of x, which means we need to put it back to the original equation so that we calculate the maximum daily income. Remember, we're calculating income right here. So we'll go, then the income then will be given by 82, the original where we have an x, we'll put 2050. Okay. Minus where we have an x, we put 2050 once again. This should be squared divided by 50. Okay, let's bring out our calculator. So we've got 82 times 2050 minus 2050 squared, and all of this divided by 50. Okay, and then we get that the income is, remember this is in rands, it's 84,050. There we go. That's our income, maximum income. Okay. Thank you so much. That's it for this question. Catch me next on question number 11. Thank you so much. Well, welcome to MV Tutors. My name is Figa Manana, and we are now doing question in number 11, which was the last question in this examination. Now, I've taken a look at it, and it doesn't look bad at all. This is the question where you should have picked up maximum marks. Okay, but let's get right into it. So it says event A and B are mutually exclusive. What does that mean? It means that they are like this. Okay, if I'm to draw their Venn diagram, so to speak. Okay, they're like this, mutually exclusive. They don't meet anyway. Okay, so that's event A and that's event B. Okay, oh, my A needs a dash. Okay, and then it says given that probability of B is equals to 2 times the probability of A, and the probability of A or B is 0.57. Calculate the probability of B. Well, since they're mutually exclusive, we know that the probability of A or B is just gonna be equals to the probability of A plus the probability of B. Simple as that. Now, what do we know? What information do we have? We have that probability of A or B is 0.57. We know that the probability of A is just the probability of A. But the probability of B is equals to 2 times the probability of A, right? 2 times the probability of A, just like that. Cool, so what can we do? Is 0.57, it's gonna be equals to 1 plus 2, that's 3 probability of A. We can solve then the probability of A. It's just gonna be 0.57 divided by 3. Let's put that in a calculator real quickly. 0.57 divided by 3. Okay, well, let's put it in decimal form. I get 0.19. So now that's the probability of A, but we're looking for the probability of B, right? And we know that the probability of B is equals to 2 times the probability of A, right? So that's gonna be 2 times probability of A is 0.19. Let's bring back the calculator. Let's just say times 2. And we get that the probability of B is equals to 0.38. If you want to convert it to percentage, just multiply with 100 times 100. It's 38%, if you like. Okay, that's it. And then 11.2 says a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. Now this is very important information, that when they take it out, they don't replace it, it's just gone. Okay, so now it says 11.2.1 2.1 says, what is the probability that the first calculator chosen is not defective? Is not. So the box has 40, right? So that's right there. That's the total. Out of the 40, how many are not defective? We're told here that 5 of them are defective, which means the ones that are not defective are 35. Okay, so 35. Now let's put that in a calculator. We're gonna say 35 divided by 40. Okay, and then we get equals to 0.875. What is the probability not defective? So you'll write this: probability not defective, not just not diff, equals to 0.875. If you want to convert it to percentage, just multiply by 100. Okay, let's go for the next question. What is the probability that if 2 calculators are selected, one calculator is defective and the other is not? Okay, this one is going to require a tree, because it's either you pick a defective one first and then secondly not defective, or you can pick one that's not defective first and then pick one that is defective. But let's make use of a tree diagram. So it's either it's not defective, and the probability of not defective, remember, is gonna, the first time it's gonna be 35 over 40. Okay, which means of defective, now the probability of defective is going to be 5 over 40. Okay, now let's go back to, if we pick first not defective, then this is our second pick. What is the probability that it's not defective? Second pick. Now remember, you don't replace them, which means you've picked 1 out of 35, which means now you're left with 34. And how many is in the sack that is left in the sack? It's now 39. Okay, but defective, if you've picked not, then secondly you still have 5 defective in the sack and there's still 39 left. Okay, now defective, if we come to this one now, where you pick not defective, how many? If you've picked one that is defective, it means you're still left with 35 that are not defective. And how many in that sack totally? It's 39. And if it's not, if it is defective, then we have, you've picked one already, defective one, which means there's 4 defective ones left in the sack, and the total number in the sack is 39. So now the question says, it says, what is the probability that if two calculators are selected, well, one calculator is defective and the other is not? So the path we'll follow is this one, where it is defective. The first one is defective and the second one is not. Okay. And then, or we can choose this path where it's the first one is not defective, okay, but the second pick is defective. All right, let's write this down. We're gonna say then the probability that one is defective and not defective, the second one is not defective, is equals to, let's start with the bottom one. Defective is 5/40 times the path we're following. Defective and not, the next one will be 35/39. Plus the other pick, it's not first, so we have 35/40 times defective, which is 5/39. Okay, let's put this in a calculator. So we have, let me just put, for ease of calculation, I'll say 5/40, okay, times 35/39. Okay, and plus I'm gonna add that to, all right, 35/40, okay, times 5/39, just like that, and we get a total of 0.2244, round off. Always take it to like 4 decimal places so that when you convert to percentage, it's gonna be 22.44%. Okay, all right, let's leave it there. Next question says, what is the probability that if two calculators are selected, both are defective? Okay, so if both are defective, then which path are we gonna follow this time? Let's go yellow. Okay, so what is that both are defective? That means I'm gonna follow the defective path and the other defective path there. Okay, so it's gonna be, let me change the color over there as well on my pen mode. Let's make it, okay, let's go for that green. So this is 11.2.3. Okay, so we're following the yellow path, so it's going to be let's choose a different color pen. Let's go purple. It's going to be, if you follow that path, a probability of first one is defective and the second one is also defective. It's gonna be 5/40 times 4/39. Let's put that in a calculator. So let's put that, it's 5 over 40, okay, times 4 over 39, and we get 0.01282. Okay. Well, if you want to convert to percentage, just multiply by 100. Okay. Now the next question says 4 different economic books and 3 different life science books are required to be placed on a shelf. If you decide to place any book in any position, in how many ways can you arrange this? Okay, let's change the color first. Let's go red. So this is the situation that we have here in 11.3.1. We've got how many? We've got 7 in total spaces. 1, 2, 3, 4, 5, 6, 7. So they're saying if you decide to place any book, so that means in the first position there are 7 books that I can put there. The next one, 6 available ones, 5 available for this position, 4 available for this, 3, 2, only 1. This, you need to multiply it, or we can just say 7 factorial. Okay, it's the same thing. So now you need to make sure where the factorial thing is in your calculator, but in this particular one, it's shift, there it is, shift x minus 1 over there. So I'm gonna go 7 factorial, and that's gonna be 50, 40. Okay, so if you are using this calculator, it's at the very same position. Switch it on. So you'd still go shift right there, and then there it is there. So you go 7, shift, and then that button there, there's your factorial sign, equals to same answer. Cool. Let's see the next question, which is 11.3.2. It says now, if 2 particular books must be placed next to each other, in how many different ways can you arrange this? Okay, so still we got 7 positions. 1, 2, 3, 4, 5, 6, 7. But now, look what's happening here. They're saying we must group them. Okay, so if I group them, that means two are available for this position. I just want to change the color. Let's go blue. So it means 2 of them are sitting together. So this 2 are gonna count as 1 position. Okay, that's the second position, the third position, the 4th, 5th, and 6th. So I've got 6 positions in total, so I'll go 6 factorial. But within this first position, I've got 2. I've got 1, 2. Okay, 1 and 2. So I'll go 2 factorial times 2 factorial. That's how it's done. So I will go then 6 factorial, shift, that sign, I get 720 times 2 factorial, 2 factorial, and my total is 1440. Okay, and then the last question 11.3.3 says if all the economics books must be placed next to one another and all the life science books must be placed next to one another, in how many different ways can you arrange this? Okay, so we still got 7 positions like this. 1, 2, 3, 4, 5, 6, 7. But now, check what's going on now. We've got, let's start with the economics books. How many economics books? 4 different economics books. So the 4 positions need to go to economics. 1, 2, 3, 4. So it's like this. Okay, those are for economics. And then the other ones, and then it says life science books. How many life science books do we have? We have 3. So these positions here are going to life science. So check this out once again. So we're going to say how many total positions do we have? We really have just 1, 2. So we'll go 2 factorial. Right? And then within this one, how many do we have? We have 1, 2, 3, 4. So we'll go 4 factorial. Okay, and then within the second one, we have 1, 2, 3 positions. So we'll go 3 factorial. Let's bring out the calculator. So first one is 2 factorial times 4 factorial times 3 factorial, and we get an answer of 288. Well, ladies and gentlemen, that's it. That's all. This wasn't so bad at all. If you had gone through studying probability, you would have answered these easily. Other than that, if there's any mistakes, please write that down in our comment section, or you have an easier way of doing it, please do comment, because we are really doing this memo without any other memo from the department, so we're just really doing this ourselves. But I hope you understood everything. This is me saying I appreciate you. Goodbye.